Okay, this is your Chapter 8, Grade 9, Algebra final review before your test. These are the questions you were supposed to do. So if you're doing this and you're following along and you're checking your work, make sure you make notes of anything you're doing wrong so that tomorrow when you write your final exam, you make sure you don't make those same mistakes. So the first questions are true and false. A quarter of x is equal to 0.4x, and the answer is false because 1/4 is not equal to 0.4. 1/4 is equal to 0.25. So therefore, the correct answer is 1/4 x is equal to 0.25x. The second question, 3/4 plus x is the same thing as 0.75x. The answer is false because 3/4 plus x and 0.75, which is 3/4, 3/4 multiplied by x is not the same thing as taking 3/4 and adding it to x. Coefficient versus constant. In question 3, 7x over 4 is the same thing as 1.75x. Well, for this one, remember when we said the 7/4 x is the same thing as 7/4 of x. These are the same thing because if you think about it, 7 over x or over 4 multiplied by x over 1 would be 7x over 4. So we can see how those two things are the same thing. And if I think about this, 7/4 as a mixed fraction is 1 3/4 x. So those are the same thing. And therefore, 1 3/4, which is 1.75 as a coefficient, is this. And therefore, your answer is true. If you want to just look at that for a second, press pause and take a peek at it, it makes sense why everything is equal. Question number 4 says 1/5 multiplied by x minus 4 is the same thing as 1.5 x plus 4. So if I was to take this expression, and I was to make it a little bit bigger so I could work with it, and I was to expand it with distributive property, it'd be negative 1.5x, and negative 1.5 times negative 4 is positive 6. So if I did that and I changed this to a fractional coefficient, these are not the same thing. So the answer is false. And the reason why is a lot of people, when they expand distributive property, forget to do it two ways. They just do it one way, and they leave this by itself, and therefore it's false. Question 5, 10 multiplied by 1/5 of x is equal to 2x. This is really testing your ability to either multiply or cross-reduce. So if I took this expression and simply multiplied the numerators, I get 10 over 1 multiplied by x over 5 is 10x over 5. And 10x divided by 5 is 2x. So the answer is true. You could also cross-reduce here and end up with 2x over 1 or just 2x. But either way, you prove that it is true, and it's 2x. Question number 6, again, true, false. It says 10 multiplied by 2 times 2x minus 2 over 5 is the same thing as 8x minus 8. So if we take this, and I think about 10 as being 10 over 1, and I cross-reduce, then really what I have is 2 multiplied by 2 times 2x minus 2, which looks really complicated. If I drew this first, I have two groups of 2x minus 2. So there's a 2x and a minus 2. And this means I have two of them, so I'm going to double it. And if I multiply this by 2, I'm going to take this. Oh, not this. Oopsie daisy. Let's bring it down here. I'm going to take this, and I'm going to double it. So, again, I'm going to show you again. So if I took 2 and a 1, this is this here. Two groups of 2x minus 2. And if I multiply it by 2, I'm going to double it. So two groups of 2x minus 2 is the same thing as 4 groups of 2x minus 2. Or, better yet, 8 x's and minus 8. Let me pause this. So when you work this out, you end up getting 8x minus 8, which means that it is a true statement. Okay? A little complicated, but not that bad. Now we get into just solving. So 2x is equal to 3/5. obviously you're going to divide the side by 2 to isolate for x. And when you divide by 2 over here, you're going to take 3/5 and multiply by the reciprocal of 2, which is 1/2, which means x will equal 3/10. In question 8, you have x divided by 3 is equal to 1/2. I'm going to multiply this side by 3 to get x. And when I multiply this side by 3, I'm going to get 3 over 2, which is equal to 1.5. This one's a little complicated because it's 1.75 times or divided by x is equal to 1.4. Remember we said before, if I multiply this side by x, I get rid of dividing by x. But I also have to multiply this side by x. So we'll end up with 1.75 is equal to 1.4x. Divide both sides by the coefficient of 1.4, and x will equal 1.75 divided by 1.4. That'll equal 1.25. So x equals 1.25. Remember, it's a two-step equation. If it was this, which is just the opposite of what it was written, it's only one step because you just have to multiply both sides by 1.75, but it's not that. It's the x in the denominator, which means it's 2 steps. Question 10. We're getting into fractions with one-step equations with fractions. And in the one-step equations with fractions, the easiest thing to do, whether it's a coefficient or constant, is just do the opposite operation. So I'm going to add 1/2 to both sides. And the reason why it's a one-step is because all I had to do was that, and I isolated for x. 1 3/5 is the same thing as 8/5. 8/5 plus 1/2 is what this really says. Common denominator will be 10. 16/10 plus 5/10 is 2 1/10 because it's actually 21/10. So your answer is x is 2 1/10. Or 2 1/10, take away 1/2 is equal to 1 3/5. Question 11. We have both a constant and a coefficient. We have a fractional coefficient and a constant of positive 2.75. So I'm going to subtract the constant from both sides. When you have more than one step, it's always easiest to get rid of that if you're isolating step by step. X divided by 1.5 is equal to -6. Multiply both sides by 1.5. And x equals -9. Question 12. This is where we start to get into, you have 2 ways you can do it. And the easiest thing to do is, because this is 2-step, we have a coefficient and we have a constant, and we have a lot of fractions. You can do it 2 ways, and I'm going to show you 2 ways. One's easy, one's difficult. Well, neither one of them really difficult, but I'm just going to clone it and bring it over here. So I'm going to do it 2 ways. The first way is the way you would have learned in grade 7. Get rid of your constant first. Subtract 2/3 from both sides. 1/5 x equals, if I'm going to subtract 2/3 over here, 15 is my common denominator. Equivalent fractions. 11/15 take away 10/15 is 1/15. Then I'm going to divide by the coefficient. And dividing by 1/5 is the same thing as multiplying by its reciprocal. So I'm going to divide by its reciprocal. That's going to get me x over here by itself equals 5/15, or in lowest terms, 1/3. Okay. Now that's a little bit more labor intensive because it involves a little bit more fraction sense, but it still works if you use it. My way, or not my way, but an easier way is to understand that in algebra, whatever you do to one side, if I multiply this side by 15 and multiply this side by 15, I'll maintain balance. And the other thing you need to understand is if you take any fraction, like let's say 2/3, and you multiply it by any multiple of 3, so 3, 6, 9, 12, 15, etc. When you multiply a fraction by any of those numbers, and I'll just choose 9, when you multiply it by 9, you end up with the number 6. So 2/3 times 9 is 6. It's a whole number. And anytime you multiply a fraction by a multiple of its denominator, you will always end up with a whole number. So if I first take this expression and rewrite it like this, and rewrite the whole sentence out like this, and then I ask myself, what is a common multiple of all the denominators? So what's 5, 3, and 15? If I think about a multiple of all those, the first multiple they share is 15. So if I multiply this side by 15, meaning I make this thing 15 times bigger, this 15 times bigger, and this 15 times bigger, I should maintain balance because I'm multiplying both sides by 15. So using distributive property, this is going to be 15 times bigger. This is going to be 15 times bigger. And this is going to be 15 times bigger. So by making both sides 15 times larger than it was, here's what happens. Because I'm multiplying by a common multiple of the denominators, cross-reducing gets me 3 over 1. A fifth of x multiplied by 15 is 3x. When I multiply this by 15, I end up getting 10, or a positive 10. And when I multiply this by 15, I get 11. So right off the bat, I can create an equation that is 15 times larger on both sides, has no fractions, and makes it much easier for me to solve. So I'm going to subtract 10 from both sides now. I get 3x equals 1, divide by 3, and x equals the same answer I got before, right here, but I did it in a way that made it so much easier. All I had to have for a skill was being able to multiply everything by a whole number, and once I did that, I created an equation that didn't have fractions, and then I could use my grade 7 algebra sense to solve for x equals 1/3. Using that same method here, if I look at my denominators, I have fractions again. I have a fraction of 10, a fraction of 2, and a denominator of 5. The first multiple that 10, 2, and 5 share is 2, 4, 6, 8, 10, 12, 5, 10, 15. The first one they share is 10, which means if I multiply both sides by 10, I'll bring it down here, multiply both sides by 10, since it's a multiple of all the denominators, I will create an equation that does not have fractions. So 10 over 1 multiplied by a tenth, 10 over 1 multiplied by x over 2, and 10 over 1 multiplied by negative 1/5. Cross reduce. So 1/10 multiplied by 10 is just 1. X over 2, or half of x multiplied by 10, is a positive 5x. And 10 over 1 multiplied by a negative 1/5 is negative 2. So the equation I create here is 1 plus 5x equals negative 2. Grade 7 in question by subtracting 1 from both sides. 5x equals negative 3. Divide both sides by 5. And x equals negative 3/5. Now, alternatively, if you want to watch the next part, I can show you how to do it without multiplying by both sides, or you can just fast forward to the next question. So I could subtract a tenth from both sides if I wanted. That works. I get half of x is equal to, common denominator is 10, negative 2 tenths. Negative 2 take away 1 over 10 is negative 3 over 10. That's fine. Multiply by 2 and multiply by 2. You get x is isolated equals negative 6 over 10, or in lowest terms, negative 3/5. Two ways you can solve this. The first thing you could do is you can multiply both sides by 10, or you can multiply both sides by 5. I will do it both ways to show you the difference. If it was me, I might just multiply both sides by 10, but both work. Oh. So let's multiply both sides by 5. And again, the difference here is multiplying by 5 still works. multiplying by 10, still balances, everything's good, doesn't matter. But the first one, if I multiply this side by 5 and this side by 5, I end up with x plus 4 on this side. And over here, I end up with negative 3 over 2, right? Or negative 15 over 10, which reduces down to negative 3 over 2. You can have either one. Then I have to subtract 4. And this is where it gets a little complicated because negative 3 over 2 subtract 4 is fairly complicated because it's 4 over 1. Negative 3 over 2 subtract 8 over 2, excuse me, is equivalent to 4. Negative 3 take away 8 over 2 will be negative 11 over 2, which is your answer, or negative 5.5. Okay? A lot of work there that I didn't want to do, but it ended up being x equals negative 5.5. Okay, alternatively, I didn't want that one. Let's take that one back. Alternatively, I could take this and instead of multiplying both sides by 5, multiply both sides by 10. And you can multiply by anything. You can multiply both sides by a chimpanzee. It doesn't matter. But if you multiply both sides by 10, the nice thing about it is this is going to give you 2x, not plus 4, but plus 8, because you have to multiply the numerators together. 2 times x plus 4 is 2x plus 8. And over here equals negative 3. Much easier to solve now. But you get the same answer. Now, this looks incredibly complicated, but it's not so bad. Let's utilize that rule we just talked about and see how well we do. So before we do this, because there's distributive property, let's just expand it before we start multiplying by a common multiple. So 3/4 multiplied by x over 2 will be 3x over 8. And I'm going to write that here, 3x over 8. 3/4 multiplied by negative 1/5 is negative 3 over 20. And I'm going to write that negative 3 over 20 here, or minus 3/20. And 19/40 is here. So now I have an equation, and I could add 3/20 to both sides. It still works. Then multiply both sides by 8, and then divide both sides by 3. Or I could be smart and multiply both sides by a common multiple of 8, 20, and 40, which is 40. So I'm going to multiply both sides. I'm going to keep this balanced. I'm going to multiply both sides by 40, which should maintain equality. But since there's two terms here, I've got to make sure that both of them are multiplied by 40, not just one of them. So 3x over 8 is going to be multiplied by 40. Negative 3/20 is also going to be multiplied by 40. Remember, put that negative sign up with your numerator. It's still a part of the equation. And 19 over 40 is going to be multiplied by 40. So we're making both sides 40 times larger. 40 over 8 cross-reduced will be 5 over 1. When I multiply 5 by the other numerator of 3x, I get 15x. When I cross-reduce here, I get 2 over 1. Multiply this numerator by the negative 3, I get negative 6 over 1, or just negative 6. And when I multiply this out, I get 19, or equals 19. This is not so bad at all now, is it? Add 6 to both sides. 15x equals 25. Divide both sides by 15. That's a 5. And x equals 1 and 10/15, or 1 and 2/3. Decimals are so much easier. Expand using distributive property is one way you could solve it. Or, let me just clone this. Alternatively, obviously, you could divide both sides by 1.2, because you learned that in grade 7. So, if I expand, 1.2 times 2x is going to be 2.4x, minus the product of 1.2 times 0.2, which is 0.24. So when I expand using distributive property, that's what I get. add 0.24 to both sides. Get 5.04. Divide both sides by your coefficient. And x will equal whatever 5.04 divided by 2.4 is. The answer is 2.1. And that's if you expanded using distributive property. So if I multiplied each term here by 1.2, I get the right equation, and then I solved it. Back in grade 8, you learned that with distributive property, you could divide both sides by the multiplier. Instead of having 1.2 groups of 2x minus 0.2, you have one group of 2x minus 0.2 equals 4. Add 2/10 to both sides. Divide both sides by 2. Press pause if you want to take a look at that, but it all makes sense. Your first story problem says the formula for speed is speed equals distance over time, where S is speed in kilometers per hour and D is distance in kilometers and time is time in hours. That makes sense. What is the time it will take a car traveling 64.2 kilometers an hour to travel a distance of 112.35 kilometers? So we have our distance. We have our time. So we have distance and we have time. Sorry, we don't know time. We have speed. We don't have speed. Oopsie daisy. Whatever. So what I'm going to do is I'm going to write my formula for A. Speed equals distance over time. And I'm going to substitute speed, which is 64.2 kilometers an hour. The distance, which is 112.35. And I do not know the time. So first step is to multiply both sides by x. I get 112.35. Multiply this side by x, and I get 64.2x. Divide both sides by the coefficient. And x, which is the distance, is equal to 112.35 divided by, which equals 1.75. What was it I was solving for? Time. So therefore, it will take 1.75 hours. And since 3/4 of an hour is 45 minutes, you can also say, or if you want to be better, 1 hour, 45 minutes. Because 1.75 hours is 1 hour and 45 minutes. The second part, B, if I can get rid of this, says how far will it take the same car to travel